Hi, in this video we're going to learn how to interpret a QQplot. The first thing we need to make sure is that our software does plot the X and Y axis correctly. So in Minitab, for instance, we need to make sure that we get the Z values here and the data here. So in Minitab, in order to get this set up, we must do transpose and also values, so that we transpose and we get the z-axis right here. Okay, so now our goal is to understand how the QQplot works. So here's a simple way to understand how the line goes. First, let me tell you that if the data is right skewed, and I'm going to draw a right skewed distribution shape here, we can clearly see that this data is right skewed, the tail is to the right. So now the question is, why is it that the QQplot is going to look like this red line? Why is that? That's the goal of this video. So to understand why the line follows this pattern, we're going to imagine that we're going to pour water into a vase whose shape is our data shape. So you see the yellow mark, and imagine now that we are pouring water here at a constant level. So because the water is falling inside this vase whose base is broad, then the water level, the rise of the water level, in the beginning is going to be very slow. It's rising slowly. So far, it's going up very slowly because the base of this vase is very broad. Now, once we pass about here, then what's going to happen to the rise? Well, it's going to go quick, like that. That's why right skewed has this shape. So how about left skewed? Well, following the same idea, we now have a left skewed data distribution which follows that shape. And now what will happen? We're going to pour water into this vase. So you can see that the bottom of the vase is very narrow, so the water rises very quickly. And once we reach about this height, the speed slows down. So rising very quickly, something like that. Okay? But then we're pouring water at the same rate, so the rise of the water slows down, and therefore the QQplot looks like this. So these red lines are QQplots. Okay, and here is QQplot. Now above we have right skewed, and this one is left skewed. Okay, now let's see typical shapes we want to understand. What if the histogram is something like this? Long tail up and long thin tail. In this case, we're going to get a QQplot that will look somewhat like this. It's going to go like this, follow the normal line, and like that. Okay? Now, what if we have a histogram that looks like this? It basically has no tails. In that case, we're going to get a QQplot that is going to look like that. Now note, I'm starting from that side. It doesn't matter, but there is a reason. Okay? Now let's try to understand why they look like this. Well, in order to understand it, let me do this. Here's a little scheme to help you remember. Okay, we have Z's here, we have the data here. Little scheme. You put a XY line here. In this part, you write fat for fat tail, S for skinny tail. Now you flip them and you get S for skinny and F for fat. So once you write that good, then when a distribution has, say, a skinny tail, we are starting on the S for skinny, and we're going like that. Now, if the right side is also skinny, it goes like that. Okay? Now, let's say that we have a case of fat tail. Well, fat tail is going to start higher on the fat, follow the center, and then goes like that. So the green is fat tail. This case of fat tail, you can see that in the histogram. If you do a histogram here and you draw the normal line, you're going to see some type of histogram that is looking somewhat like that. And that's the fat tail case. Now, the skinny tail case is going to be something, this is fat tail. And on this side, we're going to have the skinny tail, which I have one above. The skinny tail is going to look somewhat like that. But the tail is going to stretch for a long time on the Z line. So we're getting a very long tail here. Okay, so this is it. Let's do a quick review here. Here we have the right tail case. Here we have the left tail case. It's always like that. Okay, this shape is for long tail on both sides, and this reminds us of an S shape. So when I have an S shape, short tails. Okay, so here's the scheme: F for fat, S for skinny. Now on the other end we flip: S for skinny, F for fat, and therefore we follow the pattern. Now let's see some examples here with data. Here's the case of a left tail. So imagine that we are pouring water on this left tail. So we are going to fill this left tail very quickly, and we can see it on the QQplot on the right. On the right side we have the QQplot. What will happen is that S for skinny is on this side and it fills real quick. Now, once we get somewhat around the center, there is more area there, so it slows down. And once we hit this very tall bean, then it takes us a long time, a very long time to fill it. So we can see the overall pattern for left tail. Let's take a look at the right tail. On the right tail, we start pouring water right here. Because the bean is very tall, it takes us a long time for the water to rise. Actually, the level of the water it stays flat for a long time. And then notice, you see a break here. Okay, this means there is a gap. Okay, a jump upwards is a gap. Now we are here putting water in this bin. Well, it's going to be a little bit slow, okay, because it's a little tall. And then this bunch of beans is so short, the water level rises very quickly. So we have the overall pattern for right tail. Let's take a look on this one. Well, on this one, we have this strange tall bean separated. So we start putting water there, and it takes a long time to fill it. So the rise of the water is basically flat. Then here, that gap again, big jump, so here's the gap. And now we stay basically lined up for quite a while, means filling this one. And once we start filling this last one with water, it will take a long time for the water level to rise, and therefore it's going to be flat for a long time. So this is a case where it's not right tail, left tail, it's simply what you see there on the screen. Okay? Let's take a look at this one. This is the fat tail, meaning we don't even see a tail, it's a rectangle. Now we can see the S shape forming somewhere here. Okay? So this is the case of a fat tail. The S shape is right there. Let's take a look at this one. Well, this is the skinny tail. We see skinny tail on this side, skinny tail on this side. We also see a gap here, okay? And we can see the two gaps there and another gap right there. So the gaps appear right there, but the overall pattern is still valid. Remember our scheme: fat, skinny, skinny, fat. And in this case, I'm going to switch color here. In this case, we see the pattern is skinny, then the center is very pointy, so you can see that it goes almost outside the two intervals, and then it bounces back, and now that tail is stretched for a long time. So on the skinny side, on the left, long tail to the left, on the skinny side to the right, long tail to the right, and here's the histogram. And the last one is again a fat tail, so we expect an S, and here's the S, following the overall pattern of an S. So this is how we interpret histogram. The best way to think of them is really filling the shape with water. We are mainly interested in the initial ones, which are right tail, left tail, fat tail forming an S shape, and also, of course, I didn't mention it, but if the data is normal, then the dots should pretty much line up like this on the QQ plot. Wish you good luck.